So today, let's talk about reference angles. And reference angles are going to extend what we already have learned and know about 30 degrees, 45 degrees, and 60 degrees as applied to sine, cosine, and tangent. Now what we're going to do is take angles that are bigger than 90 degrees and use what we already know. So I sometimes call this the bow tie method, and you'll see why. Let's get started. Here you can see a standard angle of 45 degrees shown in blue. The other three red angles are what we call reference angles. And a reference angle is basically the quickest angle that takes you back to either the positive side of the x-axis or the negative side of the x-axis. It doesn't ever go to the positive or negative part of the y-axis, so just understand it's just to the x-axis. Now, what it creates is sort of a bow tie look. A reference angle is denoted with theta with a little hat over the top of the angle. So each of these red angles is a reference angle that's shown as theta hat. The standard angle shown is the blue 45-degree angle. There are three other angles that are standard angles in this picture. One standard angle goes to quadrant 2. What would that angle be? Quick computation, 180 degrees minus 45 degrees gives you 135 degrees. How about the standard angle that goes to quadrant 3? What would be that angle? 180 plus 45 is 225 degrees. What would be the standard angle that goes to quadrant 4? That angle would be computed as 360 minus 45. That gives you 315 degrees. Let's recall the value of cosine of 45 and sine of 45. We will apply these values to quadrant 2, 3, and 4 for each of the standard angles. Cosine of 135 degrees is going to be a negative value, not a positive value, because in quadrant 2, x's are negative and y's are positive. By definition, cosine relates to x, sine relates to y. We just pick up the negative or positive sine value in the appropriate quadrant to know the value of cosine of 135 degrees and sine of 135 degrees. Let's apply the same method to cosine of 225 degrees and sine of 225 degrees. Cosine is going to be negative and sine is going to be negative, as both negative x and negative y appear in quadrant 3. Now, cosine of 315 degrees, that will be positive, and sine of 225 degrees is negative root 2 over 2. Let's look at the standard angle now shown in blue. Again, we've marked the three reference angles in quadrants 2, 3, and 4. The standard angle is in blue, so let's figure out what would be the standard angle that revolves to quadrant 2. 180 minus 30 is 150. What about the standard angle that revolves to quadrant 3? That would be 180 plus 30, that's 210 degrees. Finally, the standard angle that revolves to quadrant 4 is 360 degrees minus 30 degrees, and we get 330 degrees. We know the value. Cosine of 30 is root 3 over 2. Sine of 30 is 1/2. We're just going to take those values and maybe adjust for a negative if need be, depending on what quadrant the angle rotated to. In quadrant 2, we would have negative for cosine and positive for sine. So the adjustment is to put a negative on the square root of 3 over 2. You leave the sine value alone as a positive. In quadrant 3, both x and y are negative, so cosine is negative as well as sine. In quadrant 4, you have a positive x and a negative y, so cosine becomes positive, whereas sine is negative for that angle. Let's look at a standard angle of 60 degrees shown in blue. The reference angles are in red, but our standard angles have to rotate from the positive part of the x-axis. The first angle you see that's in quadrant 2 is 120 degrees. The second angle you see that's in quadrant 3, that one rotates to 240 degrees. And the quadrant 4 terminal side, that's a rotation of 300 degrees. We know that cosine of 60 is a half, sine of 60 is root 3 over 2. We're only going to adjust for the positive or negative nature of the quadrant that the angle rotates to. So in quadrant 2, we have a negative x and a positive y, so cosine is negative, sine is positive. Quadrant 3, both are negative. Quadrant 4, you've got a positive x and a negative y, so you adjust and make the sign negative. To compute values of the other 4 trig functions, we need to use identities and an awareness for the values of sine and cosine. Here's an example. Find the exact value of cosecant of 150 degrees. We'll use the reciprocal identity for cosecant that says that cosecant of theta equals 1 over sine of theta. Therefore, in this case, if I were to take cosecant of 150 degrees, I would use the identity and rewrite it as 1 over sine of 150 degrees. And 150 degrees is just short of 180 degrees by 30 degrees. So our reference angle is 30 degrees. Notice too that in quadrant 2, although I have negative for x, I have positive for y. And the y values correspond with sine. Sine of 150 degrees is exactly the same as sine of 30 degrees, using that reference angle relationship. Now I have to remember that sine of 30 degrees is 1/2. So I'm looking at taking the reciprocal of 1/2. 1/2, when you flip it over, is 2 over 1, but it's better simplified as 2. So my conclusion is that cosecant of 150 degrees equals 2. My next problem involves cotangent. And again, I have to recall the identities. So I will use the ratio identity that says that cotangent is a ratio of cosine to sine. So I'm going to rewrite this as cosine of 225 degrees over sine of 225 degrees. My next step is to figure out, where does 225 degrees, in which quadrant does it land? 225 degrees is more than 180 degrees, and it is more than 180 degrees by a total of 45 degrees. So my reference angle is 45 degrees. You have negative x and you have negative y, so you have negative cosine and you have negative sine. I have the negative of cosine of 45 degrees over the negative of sine of 45 degrees. Well, negative over a negative is a positive, so my negatives end up canceling each other off and becoming a positive. And what's more is, in remembering the values, I have root 2 over 2 over root 2 over 2, and so I get 1. And therefore, I can conclude that cotangent of 225 degrees is 1. Problem done. Example 3 uses secant, and I reach back and remember, oh yeah, secant is the reciprocal of cosine. So I will write this as 1 over cosine of 120 degrees. My job now is to figure out what cosine of 120 degrees is. 120 degrees lands in quadrant 2, and it's just short of 180 degrees by 60 degrees. So my reference angle will be 60 degrees. And in quadrant 2, I have negative x, positive y. The important part is the negative x, because cosine corresponds to x. So I will write negative cosine of 60 degrees. All right, cosine of 60 degrees. So I have to remember what cosine of 60 degrees is. Cosine of 60 degrees is 1/2, but in quadrant 2, we have to remember that our 120 degrees, cosine of 120 degrees, would be negative of 1/2. Flip that over, you've got negative 2 over 1, or negative 2. So I can make my conclusion that secant of 120 degrees equals negative 2. Okay, I hope that this helps you in understanding a little bit about reference angles and how to work with them. Thanks for watching. Subscribe for more great math videos.